but we're going to try to keep it alive with ancillary structures as our next topic. And there's a whole lot to discuss here, actually. This covers the standards and specifications that are associated with things like the poles, the foundations, the supports, the trusses, the arms, for things that hold our signs, our signals, our ITS devices, and luminaires as well. And there were actually a lot of changes to these that came along right after the 2016 books were released. And we're going to be talking about some structural content that's probably, a little bit beyond the norm of what we do in our everyday life, but we do think it's really important because it kind of explains the why behind a lot of the changes that happened to some of the pay items and structures that we use every day. So one of the main things that happened that impacted a lot of the changes recently is that VDOT adopted the latest AASHTO standards and specifications. And that is this book right here. And throughout the day-to-day, I'm going to be referring to it as the latest AASHTO, and that's because the full name is AASHTO Specifications for Structural Supports for Highway Signs, Luminaires, and Traffic Signals, 6th edition, 2013 with 2015 revisions. So Carl Larson is the only one in the room that has that memorized, so we're just going to go with the latest AASHTO for the rest of the day. There were also two really relevant policies that are shared responsibility of Structure and Bridge, as well as Traffic Engineering Division. And so next we're going to talk about those two policies. Then you'll see how they kind of tie in and roll into our standards and specs as well. So the first one is S&B 90.2, which is also TE 382. And this is the policy where VDOT essentially formally adopted the latest AASHTO. So it includes other Virginia-specific guidelines, as well as how VDOT wants designers to apply these AASHTO specs for structures on VDOT-maintained roadways. So you can consider this kind of analogous to what many of us are really familiar with, which is when VDOT adopts a new MUTCD, they typically come out with a new supplement to the MUTCD that kind of adds more Virginia-specific guidance. And so that's what this policy memo really does for the latest AASHTO structural policy. But what's really important to also point out is that if any structural designer can't follow something in this policy, for any reason, that a design waiver is definitely needed. So let's get into the contents of what's in this memo a little bit. And the first one is design wind speeds. And I know a lot of us, it's kind of easier for some of us, especially for civil engineers, we don't think about things that move as much, but when we think about loads on a structure like a signal mast arm, we think about the signal heads, the weight, the dead load associated with the weight of that actual device. But what our structural friends tell us is that it's actually the wind load that has a great impact as well. And essentially the wind load is this, if you want to kind of understand it in the most basic sense. It's when you have anything that's mounted on a structure like that, and imagine a really large sign on a mast arm. The force of the wind applies a force or a pressure over that whole square foot or area of that sign, which is, of course, emitting a force on the structure itself. So if you think about it, the faster your design wind speed is, then the greater that force or that pressure is. So you got to kind of think about it. Am I in a place that has, higher speed winds frequently, or am I in a location, further west that maybe doesn't? And so a lot of that's going to explain why some of the changes to standards and specs happened over time. So fatigue category is another thing that's mentioned in this policy, and a lot of us have been hearing over the last few years this term fatigue. And I just want to help kind of explain to it on our terms and folks that we here can relate to a little bit, because if you understand at least, you'll know why and the reasons behind some of this. So if you think about fatigue like this, if you have a paper clip, and you take that paper clip and you bend it completely open so it's a long, thin line, right? That paper clip's fine, it's intact. But if you took that paper clip and you bent it back and forth in the same point 10 times, at some point eventually it's going to break. And that is essentially fatigue. So it's basically the same thing as if you have a mast arm that's kind of oscillating or wobbling. That movement back and forth, that movement essentially causes the material to weaken over time. So that's what they mean when our structural engineers say we need to design for fatigue, or fatigue governs in that design. That's what those phrases mean. It's all about the movement and designing to kind of accommodate and compensate for those things. How'd I do, Carl? All right, thumbs up. So So the next thing is what's called the fatigue importance category. And what we basically do is we take all the different structure types we have out there and we classify them based on, how important is it if this structure fails? How hazardous is it to people, to property? So it basically just assesses or accounts for the risk of that hazard. And that's what those different categories in the table mean. So if you take, for example, a large overhead, sign span structure across the entire road, that's a category 1, that's the highest. So that means that, if it does fail, it presents a really high hazard, right, in the event of a failure, as you can imagine on the road. And so we want to design those, they're in category 1. We want to design those for even, rarely occurring wind loads, right, to make sure we're really covering ourselves with that design. So there's lots of other elements in this memo as well regarding structures too, but those are kind of the highlights that are going to get to and tie into some of our standards and specs when we talk about them. So the second related policy to what we're doing here is TE 375 and S&B 89, and this is where we specify our maximum lengths for the structures. And I think a lot of us are familiar with these. They've been around for a little while. Just wanted to mention that they are clearly spelled out in the table. Something that we're still running into a little bit that people aren't picking up on is the maximum total arm length for dual arm poles. So if you have a pole that has 2 arms on it, if you add up the length of those arms, we need to be 130 feet or lower. And we also need to make sure, one of those arms isn't longer than 70 feet. So you don't want like a 90-foot arm, or, you don't want a really, really long arm and a really short arm. So any of the 2 arms need to be under 70 feet or under. Something else that this policy does is it reiterates the moratorium that we have, that we no longer erect CMS and VMS on cantilever structures. And so I don't know if you remember, how many people here remember the I-81 failure that was near a way station? That happened, there was a failure with a cantilever sign with a changeable message sign on it. And it was actually due to the fact that the wind phenomenon that it experienced was not accounted for in the AASHTO at the time. And so since that time, the department's decided that butterfly structures or span are the most appropriate for any of the VMS or CMS. So we don't want to be installing any more on the cantilever. So after the release of the 2016 specs and standards, there was a supplemental specification that was issued for poles and mast arms. So if you go to the spec book, instead you want to go to supplemental specs when it comes to our poles and our mast arms. And one of the major changes was that we separated the 2 pay items. So there's pole pay items and there's mast arm pay items. For a while they were kind of combined. And then there's also different pole types, A through F. There's a variety of different ones, and we'll get into what those are and why those are next. The good news is, though, is by doing this and having these different pole types and arm types, we are able to now have pre-approved poles. So everybody remembers back in the day we had many regional poles and regional arms, and they can just slide right in once the shop drawing's approved at the beginning of the contract, and you can use them throughout the life. And there was no review by Structure and Bridge with every single pole and arm. And so now that pre-approved products list we talked about in the beginning, our poles and our arms are going to be on that too. We have 2 vendors so far on that list. So now that will prevent us from having to submit the shop drawings and the calculations and the structural design for every pole and arm before it's put on the street. So here's our classifications of the pole and arm types, and essentially they are broken down according to the length of the pole, or the height of the pole, somehow is how I think of it, the length of the arm being used, and how many arms. And that's pretty much the key factors that break down the different types. So A through C are for your typical 19-foot pole, right? And then we also have a longer pole, D through F as well. And so pole type A is designed to hold an arm length of up to 49 feet long. And then the pole type B1 is designed to hold an arm length from 50 to 75. And so one other thing that gets factored in here is loading when it comes to those second types of arms. So the 50 feet to 75 foot length arms have 2 types of loading. There's a case 1 loading, which is lower, and it's kind of your more traditional loading where you have 1 arm over 1 approach. You got your heads probably spaced 10 to 12 feet apart, and that's your case 1 loading, a little bit more traditional. And then the same length arm is your type B2. That's the 50 to 75 feet long. That is for like diagonal arm conditions. You ever seen the arms that kind of go out in the middle of the road diagonally? And they hold heads for like multiple approaches. So you got a whole bunch of heads on your arm. So we kind of needed another loading category to account for the fact that we can't always have that perfect design with one pole, one arm per approach. We're going to need those diagonal arms, especially in a lot of constrained locations. So that's the case 2 loading, is the diagonal arm. So you're probably wondering, 49 feet, how do we get 49 feet, right? I'm sure everybody's wondering that. And Carl knows the answer. And the reason for that 49 feet is because the policy from Structure and Bridge is that anything 50 feet or longer, you have to design for fatigue. So the fatigue that we just talked about, the point is that those structures with the 49 feet or less will be less substantial structures, right? Saving us money. So that's why that 49 foot is the break point, because if you're 50 feet or more, you have to design for fatigue, which increases the size of your structure. So our arms come in, about 5 to 10 foot increments. You can see those in the standards. And if you need to cut and cap them, if for any reason you don't want that full arm length, if you need, you can just specify on the plan to cut and cap them, like if you're trying to avoid perhaps an overhead utility or something that's going to be out by the tip. So when you're selecting the pole type, it's, we're getting a little bit into signal design here, but it's really important that the designer be super familiar with everything and their surroundings when determining. Yes, please, go ahead.
I have a question.
Okay.
If I have a 75 feet arm, but the loading is more than the B2 loading, we can just use a non-standard type of pole, but we don't need to get like a waiver or something. Is that the case?
You do need, it would be a special design pole. So I'm really glad you asked. That was a note that I didn't mention. So that's a great question. It would be considered a special design pole and a special pay item. So it would no longer be the standard pole and arm. And whether it needs the design waiver, I'd have to defer. I wouldn't think so, as long as you're staying within the maximums that are in, the maximum lengths that are in the IIM.
Okay.
Would you agree with that, experts?
That's correct.
Okay, great. Thank you for asking, because it was actually a point I wanted to make earlier, so I'm glad you asked.
Question?
Oh, sure. I'm going to go ahead and repeat the question. The question was, if you have a 75-foot arm and you're going to have a loading that exceeds the case 2 loading for the B2 arm and B2 pole, can you still proceed with that design, and does it need a design waiver? And the answer is that you can proceed. It's considered a special design pole. It has a special pay item associated with it, but you do not need a design waiver as long as the maximums are staying within the limit of the IIM. Thanks again. Great, so we're designing in a 3D world, right? We have to figure out how tall or how long our pole should be. Do we need the 19 foot? Do we need the taller pole? So we really have to consider, where is that arm going to end up in real space? What is the elevation of our roadside compared to the elevation of the roadway? So where's the pole going to go? Is that way up a slope or way down a slope? That can help dictate how high your pole is going to be. A lot of times we have to get through overhead utilities. Wow, those are just kind of the bane of our existence as signal designers, trying to weave our way through those overhead utilities and the variation on those. Some of our bigger challenges are those heavier comm lines. In the winter you measure them, and they're a different dimension when you measure them in the summer. So, sometimes it's easier to go with your arm a little bit higher just to avoid them altogether. So these are all kind of things we want to think about when we're picking how tall, how high up do we need our arm to be mounted on our pole, and what length pole do we need. So related to this topic, in the update to the 2016 standards, the MP3 had a few updates as well, and the first of which was there was a maximum height over the road to the top of the signal head, that signal head could be mounted on the arm. So we've got the same minimum we had before, which is the bottom of the signal head, including backplate, has to be 16 for new construction, and then the top of it can't go above 25. So if you think about your 3-section head that has like a 5-inch backplate around it, you have kind of this 5-foot band over the road, right, where you can kind of have some wiggle room in between to work in for placement of your heads. The 5-foot band of where you need your arm to kind of be coming in. Another change that happened with the MP3 standard is we removed the upper handhole, and that's because great field input from folks that said we don't really need that. So we're hoping this change also, the handhole that was way up at the top, we're hoping that change might result in a slight cost savings as well. Something also to think about while we're highlighting the standard is there's a great TE memo, TE 379, that has a lot of really good information on how to, how small you can go for the text sizes on your overhead street name signs to really help you get those, while we're talking about signs in the master arm, get those designed correctly. So getting back to the overall clearance topic over the road, it's kind of easy to think through this in terms of an example. And there are lots of constraints to consider, and I'll give you just a minute to kind of read through that. But essentially, we've got this pole that's proposed, and it's proposed in a location where it is the elevation of the roadside itself is 2 feet above the elevation of the road. And we're thinking about our 25-foot maximum, and are we going to be okay in that world? So what this example does is it kind of shows you why it's so important that designers know the standard. Because it's very easy for a designer to put a symbol on a pole, a signal designer, and not realize that they may have put something out there that actually can't work vertically. So we're just going to walk through the example really quick. And the first thing I'll add is that on your slides, on this slide, you have a little note up there that says 3% rise for the mast arm. So you can go ahead and put an X through that right now, because that was an old thing. I don't know if you remember that angle. The arms used to go up at an angle, and they still do to some extent. And there was a requirement associated with that that's no longer in the spec. So if you can X that out on your slide, that'd be great. So for this example, we have the foundation is 2 feet above the road. And we know if we go to our PF8 pole foundation standard, that elevation of that pole foundation is also 1 foot raised, right, above the road minimum. And we'll explain a little bit more behind that as well. And then when you look a little bit further, if you look to the anchor bolt standard, we would see that the distance between the top of the foundation and the base plate, we've got about 3 inches for that spacing as well. And since this pole, it doesn't have a luminaire, our grade is not that different. We're probably talking about a 19-foot pole, so our arm is attached about 18 feet. So when you add up all these things, we've got 2 feet above grade, 1 foot raised foundation, 3 inches, 18 foot to the arm, and let's assume there's no kind of rise in the arm at all. So that puts the middle of our arm, somewhat about 21 feet, 3 inches. And so we're great. We're right in that magic range we were looking for, which is perfect. But really this example goes to show why it's so important that the designers know all of these different standards and are making sure they're accounting for all of those things when they're placing the pole and picking the pole length as well. So one of the things that came along in 2016 also with the standards in the MP3 were standardized loadings, so maximum loadings for each arm length. And a lot of us have been used to functioning in that world with regional loadings for a really long time. And now we just call them our maximum MP3 loadings for different arm lengths. And the reason for this is we realize that a lot of the structures that are going out there are probably going to have loads that are less than this shown, but this does provide additional structural capacity, so we can either move loads or add loads later, which is something we find ourselves doing a lot of. So this will add that flexibility. Now that we're having these pre-approved poles and arms coming onto the list, right? So now it's going to be the designer's responsibility. If they call out a standard pole or arm, they need to make sure that it is actually a proposed loading that is less than the MP3 maximum loading, because that's what the contractor is going to put on the street. So now that we have the approved poles, it's really the designer's responsibility to figure that out and make sure that's the case before they call them out. So we're going to get back to that. Oh yeah, please.
With these poles and mast arms being pre-approved, is that hopefully going to shorten the delivery time on order?
Yes, you are reading our minds. Go ahead, Harry.
Yes.
Answer this one.
The answer is yes. And Loudoun County's actually wanting to stockpile, to buy a bunch of standard poles of different sizes. Obviously, we've said if you're going to do that, you got to tag them and make sure you don't mismatch them. It's just one of the many things that I think is going to help speed up the process. It eliminates VDOT staff having to review the same structural drawing and calculations over and over again, too. So that's that's a plus, because nobody has any staff time to do this review.
For sure. I think there has been a little bit of an improvement in the delivery time, right? On polls lately compared to maybe a year ago? Nope, I see this and I see this. A little bit. I guess it depends where you are.
So I think this is an important insert, is that working closely with Materials Division to get the factory, if you will, pre-certified. So the factory QA/QC process is approved, and only spot checks are made to the factory, so that we're not sending a consultant typically to the factory to inspect every pole as it's being welded and put together. That's another savings for VDOT as well, that will also help out at the factory a little bit. So that's forthcoming. That hasn't happened yet, but it's one of those things that definitely, I think, you'll see in 2020 come about.
You heard it here first. That will definitely help as well. We've heard a lot about that from localities and other people, so that's really good news. So we're getting back to design wind speeds. So this table shows that we now have designed wind speeds for each of the operations regions, and they're summarized here also by district. And so this is because, if you think about it, something in the eastern part of the region or in Hampton Roads is going to be exposed to a higher wind than, say, in the western part of the state. And the intent is to have uniform poles and arms, at least within that operations region and those closely spaced districts. And you may wonder, why we did this, and this is contributing to some extent to some variation in some of the equipment. And that's because the old specs, you probably recall, we had the same pole and arm everywhere. They were all according to 90 mile per hour design wind speeds. That was statewide previously. But what's kind of hard, at least for me, to comprehend until someone really tells me, is that the pressure generated by wind is actually exponentially increased with wind speeds. So just for an example, a 90 mile per hour wind has a 65% greater pressure on the structure than a 70 mile per hour wind. So that's really kind of saying, what kind of differences we'll see in those structures and potential cost savings for a pole that's out in the western part of the state versus a pole that's perhaps down in Hampton Roads. So there was that benefit, and that is why we've chosen to have different design wins for different parts of the state. Yeah.
So does that mean a certain type of the pole that's in Hampton Roads, no, like in Northern Virginia, they cannot be used in Hampton Roads? Like an MP3 type of pole manufactured for the Southwest, it cannot be shipped to Hampton Roads and used there.
If it was designed for the Hampton Roads application, that's right, it cannot be shipped and used in Northern Virginia. Any other? Okay.
Well, if a pole designed for Hampton Roads would be over-designed.
Oh, I see your point. Oh, okay, no,
Yeah.
very good point. Yes, you could go to a lower wind speed area of the state.
Okay.
Yes, sorry, that's a great point, Harry.
So
Yeah.
Stanton, Culpeper, Bristol, Salem, Lynchburg, that pole would not work in Northern Virginia or in Richmond, Fredericksburg.
So I'm glad, I get it now, yeah, thanks.
Let me rephrase that question. So the question was, could a pole manufactured in Hampton Roads be used in Northern Virginia? And the answer is yes, because it would be over-designed. But the converse is not true because, for, say, Bristol, Salem, Lynchburg, Stanton, Culpeper, those poles could not be used in Northern Virginia because it would be under-designed.
Great answer, thank you. So this is our map of the state, and these are some contours lines that you can see with the different wind speeds. So you'll see that 70 mile per hour line that goes up the middle and cuts through the middle of Northern Virginia. And everything to the left of that is in the 70 mile per hour design wind speed section. And so, between the 70 and 80 lines are where we have our 80 mile per hour design wind speed section. So if you look at Northern Virginia up there in orange, right, we've specified that, it's kind of straddling two different wind speed areas. So we have decided that we're going to have one design wind speed for the region, though, and for the poles and arms. And that's because we want all the poles and arms to work within that operations region, right? But to some extent, if you look closely, Loudoun County here in the top of it, where the star is, that county actually falls under the design wind speed of 70, even though the whole region's getting the design wind speed of 80. So what we have decided is that we have the regional wind speed that's being applied to the structure. So that 80 miles per hour goes to the structure. That's the pole and the arm. But for the foundation itself, we know that foundation's never going to move, right? The poles and arms, we want to make sure we can use them throughout the region, but the foundation's never going to move. And the foundation also, we need a site-specific design for every foundation anyway, because the soils change, we have to get a soil test and submit a design for it. So the foundation design can be designed for the design wind speed that's in that actual spot where that foundation is going. So this kind of sums it up right here. So your arm, your pole are designed for your regional wind speed, which is 80, and the foundation itself then can be designed for wherever that foundation is going into the ground, which in Loudoun County it would be 70. And I know a lot of you probably won't even see these things, some of you, but I think it's kind of really important because everybody's been trying to wanted to get this kind of simplified and summarized, so hopefully this helps a little bit. We also now have a standard PF8 foundation for our signal poles, and the torsion wings that we had for a while in the old PF standard are now optional, but we still need to design for torsion. There had been instances where poles were kind of rotating in the wind, and I know that a lot of folks, designers especially, were having challenges kind of placing those wings in really constrained conditions with utilities and right-of-way and all those other constraints. So they're no longer required, but are optional. So some of the key features that we all need to think about is the first one that I think a lot of us have been working with a lot is there's a minimum height above the existing grade, that the top of the foundation has to be at least a minimum of 1 foot above existing grade. And you might ask, everybody wants to know why this is, but there have been instances in the past where kind of the top of foundation was really close to grade, and there's water that's settling in there, and the bolts are actually rusting out. And by raising the foundation, we're getting those bolts up out of the standing water, and we're ensuring, a longer viability for the structure. Why 1 foot? Carl?
Why not 2 inches or 4 inches?
Well, the structure bridge folks wanted 2 foot, but we got to be compromised on 1.
That's actually lower than.
Yeah.
The reason I'm asking, because foundation itself is significantly larger than pole itself. So fixed object in a clear zone, that's what it's about. So 1 foot above ground, obviously it's a hazard. So we bring in hazard more to EP. If it be reasonable, 4 inches, not a hazard, less than 4 inches. So
The pole's still a fixed object too.
yes, but pole is significantly further. Sometimes with
These poles are much bigger and beefier, with them being designed for fatigue. So it's not as small as it used to be.
I think you have a really good point. It's definitely was a trade-off. I remember when this decision was being made, we were examining everything from 6 inches to 2 feet, and we were, at the table like a lot of people do, kind of debating, what's more important? Is it this clear zone issue that you just mentioned? Is it the, what it looks like, around where it's placed? Is it also about, but we had to VDOT had to assess the risk, and the risk of these structures and making sure these structures can remain, intact was extremely important. That's how we landed at 1 foot.
So appropriate, right solution, appropriate drainage. So not supposed to be standing water, that's it, right?
Right.
Could be provided by grading, enforced grading and appropriate drainage versus to raise extra 2 feet of
But VDOT doesn't seem to do a good job of doing that.
we all need to do a better job.
I mean, we've had structures buried 2 feet.
Not good. I understand.
So we're basically just trying to get, the bolts up well above any sort of standing water or mud or
So Michelle has shown a picture of this one where it's obviously in grass area, it's above grade. If a vehicle leaves the roadway, it's going to bump the concrete rather than hit the pole and hopefully avoid damage to the pole, which is a very expensive asset. So next slide is more of an urban condition. Suppose this pole was really like right at the sidewalk. Then that would be a case where I would sign off gladly on a variance to have it only slightly above grade or be at grade if you did the necessary grading. So that would be an example of a waiver. that would easily be signed off on quickly for those kind of conditions, yeah. So if you move that pole over a little bit where it's right up against the sidewalk, yeah, I think that's an example where you want to grade and put it maybe not exactly at the same grade as the sidewalk, but an inch or so above. So anything's possible in a specific case.
And it's been our experience when we had some of these specific cases that Central Office Traffic Engineering Division is more than willing to hear the constraints and challenges. And if you look on, I think it's sheet 2 of that standard, that there are allowances when we need to locate those closer to pedestrian paths if we have to. Right now, there's a pedestrian details that were added that we want, 1 foot of space between that raised foundation and the sidewalk, or 3 feet from a shared use path. But if we need to, there's an allowance for an engineer to decide otherwise, and there's a detail to accommodate that as well. What's that?
I said, that's all wasn't gonna be done anyway, the ADA ramp and all that stuff.
Oh, yeah, no, you're right. So the PF8 also introduced some standardization in our anchor bolts, and the first one of those also is that we now have 2 nuts above the base plate, and essentially that second nut kind of prevents that first one in a way from loosening over time than it would with just 1 nut had it been there. And we've also, since 2016, we increased the length as well as the number of anchor bolts as well. I think many of you recall, and you see a lot of our old poles, right, those old 4-bolt poles that were out there for a really long time. And the challenge was that with only 4 bolts, if one of them fails, we don't kind of have redundancy in that regard. And so you will see that for poles A through D, with the shorter arms, with the 49 feet, there is an allowance for only 6 bolts if the structural calculations can support that as well. Otherwise, we have 8 bolts for our signal poles and arms. The next change has to do with test bores, and test bores are basically the soils tests that we do, and we do them in the location wherever we're proposing a signal pole. And then that information on the soil is used to, develop a foundation design and submit that in with the structural calculations. There were 2 important changes that happened. The first one is that previously we had 2 different depths required for test bores. It was 15 feet west of 95, and it was 30 feet east of 95. And now all of them are supposed to be 30 feet deep across the statewide. And there's also a minimum lateral spacing that we had between where the pole's actually going in the ground and where that soil test is performed. So for a really long time, we had to make sure that soil test happened within 5 feet of that proposed pole location. And now that has been relaxed a little bit for certain parts of the state, where we have gone up to what is 10 feet for Richmond, Hampton Roads, Fredericksburg, and Northern Virginia. The western part of the state is remaining at 5 feet. There's simply a greater variation in soils there, and that was a judgment call by the department. There were also changes to the specifications and standards for lighting poles, and LP1 and LP2 were updated in 2018. And the first change was that all aluminum light poles are now required to have vibration dampeners. And a dampener is essentially something that minimizes the range of motion or the vibration. It is literally what the name sounds like. Dampeners add a lot to the cost of poles. It could be $300 to the cost of the pole, even though they are incidental to the pay item, so you won't really see that. They'll be rolled into it. But they are necessary because there has been some pretty significant movement in some of our aluminum poles as well. It's also really important for the designer to specify on the plan whether they want the pole to be breakaway or non-breakaway. And our first preference is always to install those poles outside of the clear zone and make them non-breakaway with transformer bases. Similar to the signal poles, the lighting pole foundation also needs to now be elevated above grade. And we have different elevations here. When it's non-breakaway, it's a 6-inch min. When it's breakaway, it's 2 to 4. And in the sidewalk, it's flush. And you might be wondering why the difference between the non-breakaway and breakaway, and that's because, a fixed object essentially is considered 4 inches or higher than you have a fixed object. So in the breakaway condition, we're assuming that you are, within the clear zone then, and so we're only going 2 to 4 inches, and for non-breakaway, it's 6 inches. The MP2 is the standard that we use for metal strain poles, span wire poles, and they just had a couple of very similar updates as the MP3, which is our mast arm pole standard, especially with the signal mounting height and as well as the handhole. We just wanted to point out that there's no standard loadings for the span wire poles, though. And so the designer does need to think about that on the plan and indicate, any sort of factor of safety or additional loading for potential future loading when they're doing the design plans, because they don't have the same kind of standard loading that the MP3 does. So our pedestal poles, our little 4.5-inch poles, also had a few updates. And a couple of them had to do with pedestrian needs, like the reach distance to push buttons, which Christine is going to talk about in a little bit. But in 2016, there was a change that was incorporated into the standards to make sure that we were only using these poles for specific things like pedestrian heads, vehicle heads, push buttons and signs. And if there's anything like a cabinet or a solar panel or any other thing that we want to install on there, that needs a structural backup calculations by the contractor or the engineer or the designer to make sure that the pole can in fact hold that. And if you are going to be modifying the pole to accommodate that and backing it up with calculations, just know you need a different pay item for the foundation if you're going to have a bigger or stronger foundation. And something central office has been thinking about is perhaps analyzing this a little bit further, figuring out kind of what the maximum loadings that these poles can apply, because we know that these are highly used pedestal poles for a lot of different things. And I'm wondering if there's anything in particular that people are using these more for that we should, investigate and see whether they can accommodate those other devices. The pedestal poles, are they being used for something in particular more so? Okay. We'll have to.
RFBs,
The RRFBs?
yeah, which has all of those things you just said we can't put on.
Unless they're, but hopefully that's a good point. So you had mentioned RRFBs, they're using these pedestal poles for those, and they include, right, like the lighting, the flashers, the sign.
It's assigned the light bar, but it's also got the control cabinet and a solar panel.
Okay. And are the contractors providing the backup to go along with those when we're putting them
We
in?
never told them to,
Okay.
so no.
But that's a really great thing for us then to take a look at if they're going to be a commonly installed device. That's something we might start looking at and whether they can be accommodated with that pole. But right now, they don't fall under the standard.
That's correct. We've been on and off trying to work on an RFB spec, or special provision is what it would be, for some time, but there are other priorities that continue to come at us.
Since it's not covered, how do I install it?
Well, generally, the base itself is designed for the loading, and it has a breakaway feature to it. Obviously, the more important part of all this is that the bolts inside are tightened more than just hand tight. They need to be turned at least one turn, half turn, depending on whatever the manufacturer instruction that comes with it. Because when those are loose, that's going to be a path to failure.
Right, but if we're
But
talking about potentially having to upsize the PF2 foundation into something that's no longer a PF2, ensuring the nuts are tight, I don't know necessarily covers it.
So, well, that's step one. The other is the connection between the breakaway base and the pole and the thickness of the pole. Obviously, a 4-inch steel tube will hold all that easily. But a lot of times that's an aluminum tube, so unless it's thick enough, it could, in theory, in a high wind, fail at the weld, or the connection between the pole and the breakaway base. So we haven't analyzed everything about this, but it's working. For now, it's working, and it's on our list to continue to look at to come up with a better standard design for these.
And your point about the RRFB being something frequently it's used for, is really in line with the pedestrian safety action plans and a lot of the updates that the counties are making. So I think that this particular application of it is worth looking into earlier than potentially other maximum loadings.
The RFPs we've been directed to give it to our regional traffic engineer for review as opposed to us reviewing them. So, that's all, right away, Tim.
And I'm also reading your face a little bit, which is you don't have an answer to your question. You're trying to figure out, what do I do if I want to get this installed? And I think the answer is that the contractor should have a structural person providing you with justification showing that they can be installed. I do know that has been happening in Nova.
My district contract.
Is the RRFB a work order as well?
No, the RFB's in it on a
Okay.
PF2.
Oh, with a PF2, I gotcha, right. Yeah, no, it probably, I mean, if it,
actually came from a manufacturer showing the solar panel and everything already there.
Right, we buy it as an assembly.
Mm-hmm.
So have they taken on our liability for if the thing comes off the base?
I mean, are they providing it along with the pole and saying this works as a unit altogether?
It's all one unit.
But they're installing
Including
it
the
then
pole.
onto a VDOT PF2 foundation.
Yeah, I mean, to me, that I still think, and we should talk after for sure, but I mean, you need some sort of validation for that structurally, that it's acceptable.
Yeah, and
Which at this point I do not have.
yeah, I'm not aware of any, they've never supplied us with calculations. It's probably okay, but they're taking on the liability that it is okay. I think it's important to note that the supplier of the product's taking on the liability when they supply it and install it.
I know in other,
But if I'm the supplier, I would say, no, I'm giving you the assembly, you're putting it on your own foundation. If it's the link between the foundation and the assembly that has failed, that's you, that's not me.
so I do think in other districts, I'm looking at Nova kind of chatting back there, they are using a different kind of foundation and it is being justified with calculations, right?
Yeah, we use the Alcon Foundation. We use the calcs for it.
They provide, the contractor provides the calcs, and it's a work order for the LF1, and they provide the calcs with it to show that the whole system as a whole works. I'm wondering if maybe we can share an example.
Two might not work. With the solar.
We'll find out, right? No, I think it'd be great to exchange information on what's happening up there,
Just so I know what I need to do.
for sure. That's a good conversation. A couple other updates to the PF2 had to do with placement of them, and that's because our requirements for the reach distance associated with ADA, we need to get our poles now, that have our push buttons for pedestrians, we need to get them as close as we can to the sidewalk. And so the new drawings allow for some of the foundation to be flush and built into the sidewalk so that we can get the reach distance to our push buttons as close as possible, and Christine will be talking to that a little bit. It's just really important when we do this, though, that we're still giving ourselves, the 5 feet minimum walkable area in front of the pole base. So moving on to bigger structures, some of this was covered by Mark Lipschultz's sign section, so I won't hang long on all of these. But there were updates to the OSS1, or the overhead sign structure, in 2018. And first of all, just to prepare for some possible future loadings, we've added that it must support a CCTV camera as well as a pole-mounted cabinet. And as you heard from Mark, that VDOT did recently end the practice of designing structures for future lighting. So, basically our new sheet types are doing a great job in low light conditions. So that IIM, outlines the general position that we're not doing that anymore. So that gave us, some different clearances over the road because we don't have that luminaire right below it. So, in addition to this, the luminaire retrieval systems are no longer required that Mark talked about. And I don't know if you all know what those are, but you know how there's those luminaires that on the old signs back in the day, underneath the guide signs? And the luminaire retrieval system was a way that the technician or person working on it could access those from the pole area itself, off the road, so they didn't have to be over the road. And those, as Mark had said, were expensive. They can cost as much as $30,000 for cantilevers, or even up to $150,000 for span trusses. So, those have come off now as well as a requirement. Another change that's important is something called isolation materials. And this has to do with dissimilar metals. So if you have two certain types of metals that are touching each other, they can have a chemical incompatibility, essentially, and they could corrode more quickly. And so an isolation material is it's basically a fancy word for, like a nylon washer or a gasket, something to put in between those two pieces of metal. And a good example of that is the aluminum Z-bracket and the galvanized steel sign hanger arms. That's one area where we need something between those two because they are dissimilar materials. We've also added a butterfly structure to the OSS1. And if you check out the traffic engineering design manual, there's a really great section on it that has a checklist that kind of helps you figure out when you need a sign over the roadway versus when you can have the sign on the side of the roadway, because we would really rather have butterfly structures if we can. There's a lot of advantages to them. They don't hang out over the road. They can be installed or worked on with fewer lane closures, and they're lower in cost. So I really do recommend checking that out to help make that decision on whether you can go ahead and have a butterfly instead of a cantilever. We also had some updates to the sign panel design, specifically with the distance between slices, but since Mark covered that in the sign section, we'll keep rolling. The HH1 standard was introduced in 2016, and since then it has been revised, so that handholds 10 feet or closer to the ground, so 10 feet or lower. They need to be hinged and latchable, so these are like signal poles, light poles that are not on transformer bases, or camera poles. Basically, we need like a little star wrench or some sort of approved latching mechanism there. But for structures that are on transformer bases, we just want them to be hinged for access. And lastly, the anchor bolt standard was introduced in 2016. The photo on the left there, that's a torque wrench to help achieve the proper torque. Also, what happened with this is that ultrasonic testing became required, and that is required to be done by a third-party entity as well. And essentially, that's just that's tested, after the pole and arm are erected, and it's essentially the UT testing or testing the integrity of the material, making sure we haven't introduced a weakened state after installation. So that summarizes our ancillary structures section. That was a lot of activity since 2016. That's probably one of the areas that we've had the most changes besides pavement marking. So are there any more questions or experiences that would help us out to hear about, in addition to the great comment about the RFB and the PF2?
Do you have any developments on the compact signal?
Oh, so the question from the audience was about something called a compact signal pole. And Foundation, Northern Virginia had piloted this concept actually because the foundations and the poles had gotten bigger recently with some of these changes, and there are locations, or particularly in urban areas, where some of those sizes are really hard to get in. So Northern Virginia, in concert with Structure and Bridge and Traffic Engineering Division, they tested something called a compact or an urban pole that has a smaller foundation. It's got a smaller base plate. It can have fewer bolts. And I think what Jessica's asking.
So, let me ask you this, are you satisfied with what we came up with? You guys did most of the work, but you satisfied that this could be a standard?
Yeah.
Okay, so tell us how many you'd buy. So we have the 49 foot is in the standard already with the loading, so this would be a 49 with a reduced loading. So we could submit it to the manufacturers and have them submit it for pre-approval. That's.
I think you're wondering if there's going to actually be a standard for the reduced size item.
Yeah, I keep hearing that it's
Add
gonna
it to the
be
standard
added to the
drawing.
standard soon.
Yeah, well, we have the 49 with the loading of, let's say, X plus, and yours is more like X, the way we pared it down, because my recollection is the loading for your, what we call the urban pole, was much less than the current loading for the 49.
Yeah, in the pilot, they had used actual loading, right, plus a 5-foot section, 1 tip from the arm, which is kind of like the old school version, just to get the loadings that we were designing to the maximum for the 49 foot.
Yeah. So if you're, even one district thinks they would buy those, we'll ask we'll put it in the standard and ask the manufacturer. So under our task order, if you will give us what you've got, we will, I assume she did all the work, but, so if you'll give us that, we'll start the process of, putting it as one of the standards and ask the manufacturers they'd be willing to submit for pre-approval. And that way, in urban conditions in lovely Northern Virginia, you have a pre-approved pole. You can even stockpile it.
Well, let me ask, for the rest of the state, how often do you guys use shorter arm poles, like something that's 45 feet or less, or 49 feet or less?
So the question was, how often do you use the shorter arms, the 49 feet or less pole arms, poles? It's hard to say, right? I know, we think about this all the time. We see plans coming in, we see them going out, but if I had to actually answer that question, it's hard. It's hard to answer that question.
This is a downtown, quote, urban pole in a tight, configuration. You may have 2 or 3 lanes intersecting a 2-lane roadway, and so you don't need a super long mast arm for that. And so we were challenged with, let's come up with something that costs less, that's not so beefy, and
And
so.
then the biggest difference, correct me if I'm wrong, from my recollection, is that it's a 3-foot diameter foundation instead of a 4-foot diameter foundation. Whereas for right now, we require a 4-foot diameter foundation for all mast arm poles.
It was a big contributing factor, as well as the physical, visual impact was also lessened. I definitely think it sounds like it's worth looking into. We can also take a look at over the last couple years. It's possible to pull that data, right? To see how many of the 49-foot arms had been used recently, to see if it would add value.
Yeah, we can do that.
Okay. I think that's maybe the first step to make sure that it's going to be worthwhile as a standard. Thank you. Are there any others? Well, great. Thanks very much. We can go ahead and take a stretch break before we dive right into signals with Christine.